Today, we will talk about numbers that are used in our day to day life. So, what are numbers? Numbers are mathematical notation for counting number of objects, measuring any real world stuff, or maybe labeling like telephone numbers, codes, etc. Before we talk in detail, we should be familiar with two different terms. First, a numeral system, and second, number system. Numeral system or the system of numeration is a way to express numbers. There are several ways to express numbers. The most familiar decimal numeral system that uses the 10 digits from 0 to 1, or a binary numeral system in which only two digits 0 or 1 are used. We are also familiar with Roman numeral system in which the numbers are represented by combination of letters from the Latin alphabet, like 1 is represented as I, 5 as V, 10 as X, and so on. So we can see that a numeral system is only a way to represent numbers in different styles. Now, talking about the number system, it is a classification of numbers in mathematical context. To understand this, we will talk about a decimal numeral system throughout this video. So, we are going to talk about most widely used decimal numeral system, that is digits from 0 to 9 and some special symbol like decimal, negative sign, etc. Now, we are going to classify this numeral system, and don't forget that this classification is called what we discussed earlier as number system. The first one is the natural numbers represented by n. The numbers in this category are 1, 2, 3 till you can count. Thus, these numbers are also called counting numbers. Now, I am going to put these numbers on number line. And thus the numbers in red basket is natural numbers. Now we are going to add 0 prior to the natural numbers. Thus the new set of numbers become 0, 1, 2, 3, and this set is called whole number. Now I am going to put the number 0 in our number line and put it in blue basket, such that blue basket containing red basket is now represents the whole number, and thus natural numbers are also whole numbers. Let's see further. What if we try to put the value of x in the equation x plus 5 is equal to 3 of the number we have discussed till now? Let's try. 0 plus 5 not equal to 3. 1 plus 5 again not equal to 3. 2 plus 5 also not equal to 3. That is, not any number for x is available such that x plus 5 become 3. So we need to introduce other set of numbers. Now from the same equation x plus 5 is equal to 3, we need a decrement of 2 from 5 such that it becomes 3, and thus we get our solution. This decrement is represented by a negative sign. Applying the negative sign to the whole numbers, we get another set of numbers, that is 0, 1, 2, 3, together with -1, -2, -3. This new set is called integers, represented by z. Again, I am going to put these numbers on number line. And now the numbers on a sky blue basket along with other smaller baskets represent integers. Okay, what next? Let's say I have 1 kg of apple and I want to give half of the apple to my brother. So how we represent the number half? Again, we stuck in problem to represent the number half, and thus we need to define a new set of numbers. So in above problem, I am going to divide a kg of apple in two parts and going to represent it as 1 divided by 2. That is, one part is divided into two parts. In a similar way, we can divide any numbers into any part. For example, dividing 3 into 4 parts, which will be represented as 3 divided by 4. And thus we got a new set of numbers called irrational numbers represented as q, and the expression a by b is called fraction. Keep in mind that an integer like 5 can also be said as a rational number, as it can be represented as 5 divided by 1. That is, a number 5 is divided in one part, which gives the same number 5. Going further, let's take an expression x square, which is just a representation of x multiplied by x. Now, I am going to take an equation x square is equal to 4. It says that what is the value of x such that when it is multiplied by itself, it becomes 4. It's quite easy. X should be plus or minus 2, as a negative times negative is positive. Now, think about the equation x square is equal to 3. What do you think the value of x such that when it is multiplied by itself it becomes 3? You can take any value of x that we have studied till now. We can see that no such number available in our library of what we have seen till now. Even rational number can't solve our problem. So we need another representation of number such that when it is multiplied by itself it becomes 3. And the representation is read as square root of 3. Hence, root 3 times root 3 is equal to 3. Keep in mind that minus root 3 is also possible. And thus, we got another set of numbers in our library called irrational numbers, represented as q dash. And the rational and irrational numbers together called real numbers, represented as r. Keep in mind that the real numbers can also be expressed in decimal form, like 1 divided by 2 has the value 0.5, under root 2 has the value 1.414, of which we will discuss in another video. Now, I am going to put these numbers on number line. And thus the numbers on the green basket along with other smaller baskets represents real numbers. Here I have represented only irrational numbers instead of both rational and irrational numbers on number line to reduce overcrowding of numbers. You must be wondering that how the irrational numbers like under root 2 can be measured. This comes from Pythagoras theorem. Putting the respective values of perpendicular and base on the given equation, we got hypotenuse as under root 2, and thus the length of the hypotenuse is under root 2. In a similar way, we can measure other irrational numbers. One last moment. Think about the equation x square is equal to minus 1. What should be the value of x such that when it is multiplied by itself it becomes minus 1? You can pause the video and use this library too to get the value of x. And you couldn't find it, could you? Okay, the solution is plus minus under root minus 1. And interestingly, the number under root minus 1 is represented as I. But this number is amazing. It can't be measured, and thus we can't put this number on our real number line. Let's see other examples. Under root minus 2 is equal to under root 2 into under root minus 1 is equal to under root 2 into I. Under root minus 4 is equal to under root 4 into under root minus 1 is equal to 2 into under root minus 1 is equal to 2I. So not only we just need another representation of numbers, but also another number line to put these numbers. That's called imaginary number line, and the numbers are called imaginary numbers. Now, the real and imaginary numbers put together in the form of a plus bi is called complex numbers, where a and b are real. Example 4 plus 3i, 5 plus root 2i, etc. Now I am going to put these numbers on new basket. Thus, the orange basket along with other small baskets represent complex numbers. Hold on. Are we done with numbers? Think about these equations. Do we need other set of numbers to be represented? Discuss it in comment section.